Hello everyone, today let's solve the problem number 48, rotate image, right? So what the question states here, we are given an n into n matrix, you can clearly see here, we are given an n into n matrix, square matrix, and we need to rotate it 90 degrees clockwise. So we need to rotate this one 90 degrees clockwise, means from left to right? So modifying it in place, so we have to modify in place. This one we have to keep in mind, just keep this in mind, we have to modify this one in place without using extra space for another matrix. So we shouldn't use any extra space for another matrix, right? So we don't have to use the another space or the another resulting array here. In this case we have to change only the matrix in place, right? So we have to rotate it 90-degree clockwise, modifying it in place, means without using it extra space for another matrix, right? So here you can clearly see the matrix. Here you can clearly see, so 1 2 3 4 5 6 and this one 7 8 9 we have, right? Here 1 2 3 4 5 6 7 8 9. So here you can clearly see here transposing means 7 4 1, this has to be in the first row, so that's what 7 4 1, and 2 4 5 this one 8 5 2, sorry, 8 5 2, this has to be in the second row, you can clearly see here 8 5 2, finally 9 6 3, right? So here you can clearly see 9 6 3, this one we have to rotate it 90-degree clockwise. So when we rotate this one 90-degree clockwise, the output that we get here is 7 4 1 8 4 2 and 9 6 3. They have clearly shown this one in the figure, right? I hope this is clear. So also let's see the second example as well here. 5194, this is like here this one we have to consider, right? Sorry, 15 13 2 and 5, 15 13 2 and 5, this one 14 3 4 and 1, 14 3 4 and 1 here. So 12 6 8 and 9, 12 6 8 and 9, you can clearly see here. The final one here is 16 7 10 and 11. Here you can clearly see 16 7 10 and 11, right? So here you can clearly see, that's what we got in first row, second row, third row and fourth row. 1 2 3 and 4. So we got this one here. I hope this is completely clear, right? So first let's discuss the approach, so how we can achieve the solution, I mean how we can get this output. So how can we articulate that one in the form of code? Let's discuss the thought process, let's discuss the approach first, followed by the edge cases one by one, and then finally discuss the complexities for the code that we have written, right? So let's discuss the approach first. So here let's discuss the approach step by step. In this case we are going with the transpose and reverse approach, a simple math approach, transpose and reverse. So just keep this in mind, we'll be going with transpose and reverse, nothing but simple math approach here, right? So first example here, I have considered the same example, first example that they have shown or that they have given in the question. So that's what I'm considering here, so that it will be easier to understand. We have already discussed about the first example, right? So this will be easier to understand in this case. So let's discuss the first example in this case. So first step here is we will reverse the matrix vertically. So we have to reverse the matrix vertically. In this case we have 1 2 3 4 5 6 and 7 8 9, right? So we can write in this way 1 2 3 4 5 6 and 7 8 9. What we have done here in this case, so we have reversed the matrix vertically, means we have swapped the first row with last row. You can clearly see here we have swapped this one to the first row, and the first row comes here to the last row, 7 8 9 4 5 6 and 1 2 3. You can clearly see here, this is the first step. Let's move on with the second step here, transpose the matrix. We are transposing the matrix, or we have to transpose the matrix. Here we will swap matrix of ij with matrix of ji. Here we are swapping the matrix of ij with matrix of ji in this case. So we are going with index here ij 0 0 1 1 2 and 2. Here matrix of 0 1 we are comparing with matrix of 1 0. right? Just give me a second here. So did I get confused here? So this is correct itself, right? So we are swapping the matrix of ij with matrix of ji, where I less than j. So here where I less than j, you can consider this as well. This is fine. So ij in this case 0 0 1 we are considering. I is nothing but 0 0 1 we are considering. 0 1 0 2 1 2 j. This one here. Here matrix of 0 1 we are transposing this one, matrix of 1 0. Then 8 becomes 4 here, right? So matrix of 0 2 here becomes 2 0, because 0 2 we are reversing this one, right? This will be 2 0, 0 2 will be 2 0, 9 1, and matrix of 2 1 here 6 and 2 here we get, right? I hope this is clear. So final matrix after the transposition that we get here is 7 4 1 8 5 2 and 9 6 3 here. 7 4 1 8 5 2 and 9 6 3 we got here, right? I hope this is completely clear. This is the final matrix after the this one transposition. So this is the same output that they have given in the question, right, for the first example. So here you can clearly see 7 4 1 8 5 2 and 9 6 3. 7 4 1 8 5 2 and 9 6 3 here. You can clearly see here, right? 7 4 1 8 5 2 and 9 6 3. So this is the solution we got here, right? So this works absolutely correct in this case, right? So because the output that we got and the output they have given for the question one is same. So we saw step-by-step approach, right? So reversing the matrix vertically, first step, and second step is we will transpose the matrix, and we will, within transposing the matrix, first step what we'll do, we'll swap the matrix of ij with matrix of ji, where I less than j. This is fine. The final step here is final matrix after transposition here, matrix 7 4 1 8 5 2 and 9 6 3 we got as output, same thing, final output 7 4 1 8 5 2 9 6 3, which is equivalent to the output that they have given in the given for the example 1 within in the question, right? So this works absolutely correct. So this is the approach that we will be going with. So let's see that one after discussing the edge case. How can we articulate that this one in the form of code? This is the thought process, right? So we have discussed. So let's see the same thing after discussing the edge cases. Let's see the same thing. How can we articulate that one in the form of code, right? So let's discuss the edge cases one by one. The first edge case that we will that we have to discuss here is or that we have to go with here is smallest matrix. Nothing but here 1 into 1 matrix we have considered. You can clearly see only one element is there. So output will be quite obviously here this one itself, right? So we have only one element, right? No change here. Since it's just one element, there is no change here. So output will be same here. The second edge case we will be going with here is even sized matrix input, and this one we are going with, right? So input we have got here as 5 1 9 11 2 4 8 10 13 3 6 7, and final one is 15 14 2 16 we have got here. So output will be in this case this one. First we have to consider this one, right? 15 13 2 5, and the second row we have to go with this one, 14 3 4 1, 14 3 4 and 1. So this is fine. The third one we are going here with us this one, 12 6 8 and 9. So this one will be 12 6 8 and 9. This is fine. The final one we went with here is 16 7 10 and 11. Here 16 7 10 and 11. This is fine. So this is the output that we got here, 15 13 2 5, 14 3 4 1 and 16 7 10 11, right? So I hope this is clear. So this is the output that we got, right? So I hope these edge cases are completely clear. The first edge case that we went with here is smallest matrix, and the second edge case that we went with here is even sized matrix. We saw how we got the output, right? So even sized matrix, this is. So this is 4 into 4 matrix, right? So I hope this is completely clear, right? So next what we'll do, let's start writing the code. I hope the approach as well as the edge cases are completely clear. Now we will start writing the code. So let's start writing the code here. So they have clearly mentioned here the return value. So we shouldn't return anything. Instead, we have to modify the matrix in place, right? In test, instead they have clearly mentioned here. So let me remove this one so that it looks clean right here. So the first step here is we will be making use of length of the matrix several times. So I'll just assign this one to the variable n, right? Matrix dot length. This is fine. So the second step or the first step we'll be going with here is let's consider this as first step because just we have assigned this one, right? Length of the matrix to the n here. This is fine. So the first step here is reverse the matrix vertically. Means we will be reversing the matrix vertically in this case. So we will iterate till middle row. We will iterate through each column. So first what we will do, we will iterate till the middle row. First let's write that one so that we will not get confused, right? So that I will not get confused first. So we have to iterate till the middle row. So how can we articulate that one in the form of code? R equals 0 and row less than this one, math.floor, or I'll just go with the double tilde operator here. This is fine. You can use math.floor as well. N by 2. So we are iterating till the middle row, right? So either you can make use of right shift operator, or you can make use of math.floor, or you can go with the double tilde operator. I'll just go with the double tilde operator, right? So I'll just let's increment the R here. So next step is we have to iterate through each column as well. So one more for loop. So let C equals 0, C less than n, and C plus plus here. This is fine. So we have iterated through the middle row, and now we are iterating through each column. The next step here would be we will swap the first row with last and the second row with second last, right? So we will swap the first row with last, and we will swap the second row with second last here in this case. So let me give here matrix of R C, this one, matrix of RC, comma matrix of n minus 1 here, this one, C here. This is fine. This will be equal to we are swapping, right? We can just give here same thing. Let me copy this one and make the necessary changes here. So here, as we are swapping this one, matrix of first here, this should come n minus 1 and C. The next one we have to give first here, right? This one has to come first, and this has to be R and C as we are swapping here. What we are doing in this line here, again I'm telling, we are just swapping the first row with last, nothing but also second row with second last. So don't forget this, swapping first row with last and second row with second last. Simple, right? So here within this one, let me format the code once. I'll explain this one once. So here we are reversing the matrix vertically. That's what you need to keep in mind. So first step was in the approach, we have to reverse the matrix vertically, and the second step was we have to transpose the matrix, right? So here first step was first step within the reversing the matrix vertically. Here we have to iterate till the middle row, and we have to iterate through each column, and then finally what we will do, we will swap first row with last and second row with second last. I hope this is clear. So the next step here would be transpose the matrix in this case. So the next step, transpose the matrix in this case is we have to iterate through the rows here for let R equals 0, R less than n, R plus plus. This is fine. So we are iterating through the rows. Next step, we have to consider only the upper triangle, right? Transposing the matrix we saw in the second step, if you remember. In the approach, we clearly saw that one, and also we discussed the final matrix as well. So how we got that one, right? First we went with the row, changed the first row to the last row and last row to the first row, that one. Next we saw the transposing the matrix, transpose the matrix and depth correctly step by step, and then we saw the final matrix, right? So here we are going with transposing the matrix. So first we are iterating through the rows, and second step here, after iterating through the rows, we are considering only the upper triangle. So here for loop, let C equals R plus 1, let me give here, and c less than n. Let's consider c less than n. Then finally we will go with c plus plus. Nothing but we are incrementing the c here. Nothing but we are considering only upper triangle. So the final step here is we are swapping the element at r comma c with c comma r. So I'll just copy the same thing and make the necessary changes. I don't want to type this one again entirely, right? So here we are just swapping r comma c with c comma r, right? So this has to be c. What did I do here? Oh, fine. This is fine. C comma r. This is fine. Matrix of RC, matrix of CR. Here this one would be again matrix of R. First we are swapping this one, right? This one will be CR, and here comes RC. CR and RC. This is fine. So let me format the code once. So the final step. So we have to. This is it, or we have to return something. This is it, right? For this one. So after transposing the matrix itself, we will get the result. So we don't have to return anything. So they have clearly mentioned. I forgot here. So we have to. This one. Yeah, we have to rotate the image in place, which means we have to modify the input 2D matrix directly, and we should not allocate another 2D matrix to do the rotation. Means we should not return anything. So before deleting this one return value, so they had given here, right? I had deleted that one just for the cleanup purpose. So here we don't have to return anything. So let me format the code once and let me hit the run button. Let's see. A wrong answer we are getting. What is wrong here? The last element 5. So order is wrong here. We are getting the same element 15, 13, 5, 2, 14, 1, 3, 4, 12, 9, 6, 8, and 16, 11, 7, 10. So we are getting the order wrong. Let's see. Let's see what is wrong here. So here in the line number 6, after this one, iterating through each column in the line number 5, here we are swapping this one, right? We are swapping the first row with last and second row with the second last. We have written wrong code here. This has to be n minus 1 minus row r. So I have considered only n minus 1 here. In this case, I'll just change this one to n minus 1 minus r in this case, right? So this will be matrix of r and c. This is fine. This remains same, but this one has to be n minus 1 minus r. So this is fine. So let me format the code once and let me hit the run button. So I hope this works. Yeah, you can clearly see here the sample test cases are getting passed here. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed here. Means the code works absolutely correct in this case, right? So here let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is transpose and reverse. So the approach that we went with here is, we know this one, we went with transpose and reverse, right? So what would be the overall time complexity here? Overall time complexity would be big O of n to the power of 2 here, or n square. So as we are going with 2 for loops here, right? For loop within the for loop. So you can clearly see here. So this will be n square and this will be n square as well. So overall time complexity would be big of n square, right? So what would be the space complexity here? The overall space complexity would be big of 1 here, right? So why the time complexity here is big of n square? Because each element is swapped once in reversing the matrix. You can clearly see here. Each element is swapped once in reversing the matrix, and each element is swapped once in transposing the matrix. This one, line number 6 and line number 12 here, you can clearly see. So overall time complexity, or the overall complexity, would be big of n square here, right? So what would be the space complexity here? The space complexity is big of 1 because we are modifying the matrix in place. So we are not using the extra array right here. So in the question they have strictly asked, we have to modify the matrix in place. So no extra space is required here in this case. So overall space complexity would be big of 1 in this case, right? So I hope the time complexity and the space complexity for the code that we have written is completely clear, right? I hope the solution or the code that we have written is also clear, right? So for now, this is it. Thanks for watching, guys.